So here the problem is given that find the magnitude and direction of the single force that brings the following system of concurrent forces into equilibrium. So equilibrium means that will be the one force which will be replacing the resultant of all the forces. So here the forces are acting like this, different types of the forces in different directions from a single point. So which represents the concurrent forces, the system of concurrent forces. So F1 is acting in horizontal direction, that is 20 newtons, and F2 at an angle with respect to F1 or X axis, which is the value is given 25 newtons. Next F3 is 10 newtons and F4 is 30 newtons. Okay, so total four number of forces are acting from a single point. So these are all concurrent forces. Concurrent forces means the forces number of forces acting at a point, at a single point. Okay, so for this system of forces we need to find out one resultant force which will be producing the same effect as all these number of forces are producing. Okay, now for finding that, first we have to find out all horizontal forces. That means sum of all horizontal forces and sum of all vertical forces. Here means, so whenever the forces acting at a particular angle, we can divide them into two components, like horizontal component, vertical component. So for finding the resultant force, first we need to find out sum of all horizontal components of these forces and sum of all vertical component of these forces. So for that, here I am giving the angles 40 degrees. F2 is acting at an angle of 40 degrees and F3 is acting at an angle of 50 degrees with respect to the y axis, and similarly same F3 is acting at an angle of 40 degrees with respect to the x axis. Okay, here I have already told you, whenever the force is acting at a particular angle, we can resolve it into two components, Fh and Fv, F horizontal, F vertical component. Okay, so similarly first we have to find out sum of all horizontal components of each and every force. So first I want to take F1. F1 is already acting in a horizontal direction, so that means F1 is itself its horizontal component. There will be no vertical component, that component will be 0. Okay, so first sum of horizontal components means we need to consider F1 as a horizontal force because it is acting in horizontal direction only, so take 20. And again next plus we need to take horizontal component of F2. F2 is acting at an angle of 40 degrees. So how will be the horizontal component means it will be F2 cos theta. Okay, now horizontal component is F2 cos theta, that means that will be acting along F1. Okay, so the resolution already explained in previous videos. Please go through that videos how to resolve one component into two components. So one horizontal component will get whenever the angle here it is making with respect to the x-axis, the horizontal component will be with cos theta and the vertical component will be with sin theta. Okay, so for F2 the angle of inclination is given with respect to x-axis only. So in this case we need to consider F2 cos theta only. So F2 means 25, so 25 cos 40 degrees. So that is the horizontal component of F2. Next we need to consider F3. So for this F3 also we need to consider the horizontal component. Okay, horizontal component, when you consider 40 degrees, here the direction is in negative direction of x. So that's why we need to take the negative sign. And here 40 degrees with respect to the x-axis only. We are considering 40 degrees. So when you consider 40 degrees, so the horizontal component will be equal to the F3 cos 40 degrees. So again here 10 cos 40. We can consider 50 also, but I don't want to consider that. So I have considered 10 cos 40. Okay, so again here F4 is there. So F4 is already acting along the y-axis. So that means there will be no horizontal component for this because it is already having a vertical direction. So whenever the force acting in vertical direction, its horizontal component will be 0 because there is no inclination with respect to y. Okay, so like that there will be no horizontal component for F4. Okay, so finally these are the values required for finding the horizontal component, so which will be equal to 31.49 newtons. Use the calci for solving this equation, so automatically we will be getting positive value of 31.49 newtons. Similarly we need to find out vertical component. So again consider F1. I told you whenever it is acting in horizontal direction there will be no vertical component. So for F1 there is no vertical component. For F2 there will be vertical component with respect to the inclination which is given with respect to the x-axis. So vertical component will be F2 sine 40 degrees. F2 sine theta means F2 sine 40 degrees. So again equal to 25 sine 40. That is over. Next, for F3, we have to write a vertical component here. So how to write the vertical component? Plus 10 sine 40. Okay, so I'm considering again here 40 degrees. So when you consider 40 degrees, here the cos theta will get, here sine theta will get. If you want to consider this 50 degrees, which is an inclination between y axis and the f3, here we'll be getting 10 cos 50. But here again I'm not considering 50 degrees, I'm considering only 40 degrees. So here 10 sine 40, which is the vertical component of f3. Again here F4 is there, which is already acting in vertical direction only. So directly 30 newtons we have to take, and again here it is acting in downward direction, which is in negative direction. So again we have to take negative value of 30, which will be equal to, again the value by calculation will be getting minus 7.5 newtons. So minus means again here the vertical sum of all vertical forces will be acting in downward direction. Okay, so after getting these two FH and FE, that is sum of all horizontal forces, sum of all vertical forces, we have to find out the resultant force. So already I've given the explanation in previous sessions. What is the resultant formula? Resultant formula will be equal to square root of sum of all horizontal forces square plus sum of all vertical forces square. Okay, substitute these two values in this equation, we will be getting the required resultant value as 32.37 newtons. Okay, so this is the way of finding the resultant force. Next we can find out the theta also. So that means the resultant force, it is acting with respect to x-axis. Okay now, so theta is equal to tan inverse of sigma v, that is sigma fv by sigma fh. Okay, so substitute the values, again here the theta value you will get by calculating the equation. So 13.4 degrees. So how to represent means FH is positive value in positive direction and F is negative value in negative direction, and the resultant force will be in downward direction at an angle of beta with respect to x-axis. Okay, this beta will be equal to, again here, 13.4 degrees. So when you consider equilibrium, if he has asked you to find out the equilibrium also, so the equilibrium will be equal to the same resultant force but in opposite direction. So how it will be acting means, in this opposite direction the equilibrium force will be acting, which is the equilibrant, which will make the body to be stable condition. Okay, so this is the way of solving a simple problem when a system of concurrent forces is given. So in that we have determined the resultant force and the angle of inclination of the resultant force with respect to the x-axis. So I hope you understand the simple problem. So once again, thanks for watching my video. If you still have any doubts, please feel free to give a comment to my video, then I'll try to clarify your doubts. And once again, thanks for watching and please subscribe to my channel. Thank you all.